Okay, so my name is Joel Freedman. I'm the head of user-centered design at the Satellite Applications CATAPULT. My background is in product design and mechanical engineering. The course I studied and then followed on with a master's was a split between straight mechanical engineering, just how things work, how to understand materials, how to kind of build stuff, and product design, which I guess was trying to tell you what to build. So the product design side was very much focused on understanding people, understanding opportunities, coming from a point of view that product design is kind of cutthroat in that you can design something and people will either buy it or they won't, and if they don't, it fails. What gives you your competitive edge is understanding why someone would buy your product over someone else's. So to get that, you need to understand people, and the method that we were taught was known as, referred to as human-centered design. That really is around putting people at the center of your design process and basing your design on an understanding of them. So who are they? What do they do in their life? What are their habits? What are the struggles they have? What are the motivations they have? And by starting to understand how to get that information from interviewing, from observing, and then starting to lay it out, synthesize it and categorize it, visualize it in different ways, you can start to see insights about that person where there are opportunities for some sort of product that will really fit into their lives and really help them with their problems. So that was the course I did. I wasn't really sure what I would do with it. I just knew that I wanted to my job to be getting paid to come up with ideas. Actually, that was, when I went to university, that's what I wanted. So now I'm working at the CATAPULT, the Satellite Applications CATAPULT, which is one of a number of technology research innovation centres across the UK. They were set up by the government. The first ones were set up about 6 years ago in areas where the government identified there was big potential for future economic growth. And a study was done to look at how the UK could foster this type of innovation and support the commercialization of it. And they looked at a model in Germany called the Fraunhofer Institutes and saw that if they could identify these key areas of technology and set up centers where there's expertise of technical, business, design and links to academia and industry, they could create an environment that could support the growth of that sector. They were set up to address initially two kind of key gaps, barriers to growth in those areas. The first was identified as a barrier of the commercialization of academic research. So the UK traditionally is very strong with academic research, but not as good actually turning that into real commercial opportunities. The second was, how do you go from being a small, medium enterprise, or an SME, we'd call them, to scaling up, to being a large company? Part of that is around understanding how you develop a product to be suitable for a larger market. Another part is finding that market, but another part is understanding how to run a business that size as well. So it's not just a case that you could be a small company and all of a sudden you hit this big market and you've got like millions of pounds of orders and you just carry on. There's a whole load of changes that would have to happen. And so the catapults are set up to partly research the kind of cutting edge of technology and partly support people who could feed into that and turn that technology into something commercially sustainable. So this particular catapult, the Satellite Applications CATAPULT, is focused on applications of satellite technology. How can space technology be useful here on Earth? Space technology is a really interesting industry to be part of, because although the space industry is an industry in its own right, it's actually an enabler for countless other industries. Satellites can be used to broadcast information. As everyone knows, they can be used to help you know where you're going. They can also be used for agriculture. They can be used for disaster recovery and monitoring. They can be used for climate change adaptation, for building future cities, for monitoring transport links, for monitoring infrastructure. The amount of different industries that are enabled by satellites are countless, really. And so what that means is working here is extremely varied and extremely interesting, and is one of the reasons that I love it. We get to look at how this technology can be applied to solve challenges that are not just in the UK but are global as well. Satellite technology can be roughly split into three buckets. The first is communication, so passing data all around the world, creating connectivity everywhere, really, from Internet of Things devices, sending very small bits of information. You know, it could be a sensor on a plant in the middle of the desert telling you how much rain there's been, versus streaming video, Skyping with your family while you are in your autonomous vehicle driving across the UK as well. So the range of communication, it's really about giving us access to information wherever we are. The second bucket is navigation. So understanding, or positioning really, understanding where on Earth we are and where other things are. You know, that's something that is so fundamental now, we almost take for granted, that we can position ourselves, that we can type in the name of a shop on Google and know exactly where it is. Doesn't matter what country it's in. That ability to know where things are and know where you are is hugely powerful. And there's another level to it, which is not just where things are, but how they're moving as well. So by seeing how something's moving, you can start to infer characteristics about its behavior. So for example, we have a demonstrator that was a project that turned into a commercial service, which is focused on illegal, unreported and unregulated fishing. It's a huge problem around the world. The ocean is very big, it's very difficult to know what boats are doing. But actually there is a system on boats that is mainly for identification and collision avoidance called AIS, and it can be tracked from space. So if a boat has its AIS on, broadcasting who it is, you can see where it's going. And so you can look at, okay, well here's an area that's protected and here's a boat going through it. And if I look at the way it's moving, based on how the system's been trained, it knows that, well actually that is very indicative of tuna fishing, or two boats moving together is very indicative of a transshipment as well. So a system can start to flag up areas of suspicious activity. Even, you know, there was a boat heading towards this protected area and it turned off its AIS and all of a sudden it disappeared and then it turned back on over here. There's certain things you can start to infer. So that's the movement, position, navigation. And the last is Earth observation, remote sensing. To me that's one of the most mind-blowing areas, because you're taking sensors that are looking at the world like cameras, and from a picture that could be kilometers across, being able to look at like the health of a plant based on the amount of green light that's reflected back. You could be looking at where there's been a change in the landscape due to millimeters of height difference. You can look at the chemicals in the atmosphere, pollution in water. Anything you can sense on Earth, you can likely try and sense on a bigger scale from space. And that becomes really interesting as well when you start adding other technologies like computer vision and machine learning as well. So if you can train a computer to start looking for certain patterns, certain features, and you're getting this global view of how things are changing, you can very quickly set up alerts to warn you of natural disasters, of buildings that might collapse, of areas where maybe there's people who are, I don't know, in need of help. They're lost at sea, they're moving around in a certain way, they're polluting a river. There's all sorts of things you can do with it, and it's kind of infinite and endless in a really wonderful way. So that's the remote sensing side of it as well. So, okay, one question then is, you have these technologies, so how does human-centered design or user-centered design actually fit into that? We can say, I think that if I compare an image today with an image yesterday of a forest, I can see whether there's any trees that have been removed. So therefore, I think that you could use satellites to solve a problem of deforestation, illegal logging. Okay, it's a good premise. But going from, I think I can do this with this technology, to I've developed a service that people are using, there's a big gap. And one of the first parts of going through that process is to understand who it's for, who actually is your user. To design any sort of service, you need to understand who is going to use it. What is it they're doing now? What is it that is not working about what they're doing now? What is the actual information they need to see to be useful? You know, are there lots of different people tracking these trees? You know, there might be rangers on the ground, there might be government organizations in a different part of the country, there could be NGOs in another part of the world also looking at this. So who's doing what, and how can you make sure that what you're creating is not just going to disrupt people's daily activities necessarily, but it will fit into it. Being disruptive is great. Disruptive technology is good. Disrupting people is not so good. What you want from your applications is that they're smooth, is that they're almost instinctual, and that they kind of know what you're going to want to do before you do it. And that doesn't happen by accident. That happens through really understanding what it is people are going to want to try and achieve, and then turning that into a set of specifications and designs that can then be given to the technical people to say, okay, we know what we need to do, we know what they want, let's go and build it. So part of it is our team is a research team. We go and talk to different users around the world to understand what their challenges are, and identify the areas where satellite technology could solve them. The next bit is then we take that information, working with technical teams and business teams, and we come up with some concepts. Now it's really important that the business team's there as well, because you need to have this kind of trilogy of technical, business and design. So it needs to work technically, yep. It needs to solve people's problems, they need to want to use it, but also it needs to be a sustainable business, and needs a sustainable business model. You can't just say, I've got this great technology, they really want it, I'm going to charge like £10 million for it, because no one's going to buy it. But likewise, you could have a great technology that's like super cheap and no one cares about it, so that's not going to work either. So it's really important that from the beginning we have these multidisciplinary teams together, and you're looking at not just what is the problem that someone has, but what is the value of that problem to them. And you can kind of quantify that in a number of ways. You know, you can look at, I'm going to design a solution for you. If you're going to pay for that, either it needs to save you some money that you're already spending, or it needs to help you generate more money. As long as the cost of my solution doesn't outweigh any of those, then we've got something good going on. So we get those teams together, we conduct research, we then start to put together some ideas of, okay, what might this look like, what sort of technology could it use, where could the data come from, how much might it cost, and we put together some pretty basic kind of sketches, models, and we take them to people, and we get their opinion on them. We say, look, does this make sense? Does this look like it would solve your problem? Is there more information you'd need? Would you pay for this information? Who else do you think would benefit from it? And very early on, start to iterate the idea based on that user feedback, which means that we don't just go away, spend hundreds, thousands, millions developing something, and then go, oh, here you go, and you're like, it's not quite what I wanted. We're constantly checking and iterating our designs, which is a kind of course correction. Because when it comes to design and development, you're really looking at a kind of costs committed versus costs incurred model. So by that, the decisions you make early on commit you to costs. If I'm designing a chair for you and at some point I say it kind of has to be gold, I think it's going to be gold, and I put that down, I'm kind of committed now to paying a lot of money to make that chair. Now, if early on someone goes, sorry, why is it gold? And I'm like, well, I just thought it would be great. And anyway, we go through that conversation and I go, okay, maybe we just like spray paint it gold instead. That's fine. We've now saved that money. If I don't have that conversation till the end, it's a little late for that. It's really easy to change your mind and make decisions early on in the process. So the more you can have those conversations, the more you can iterate and play with different ideas early to land on something suitable, the better your design will be. So part of what we do is the development of applications, from research to design to testing. Another part of what we do is taking that overall process and advising companies on how to do it. So not doing it ourselves, but working with startup companies, working with academics, getting a designer, a business strategist, and a technical person in a room with a business, and helping them to really think about who their customer is, think about their product and their service, and take them through that same process based on our learnings, so that they can get to a point where they have a really robust, scalable, sustainable business model. So we do that for small companies. We do it with big companies as well. Part of our methods normally involve bringing together lots of different people, different stakeholders, and getting them to think creatively around their problems, their challenges. And these sort of co-creation sessions are important for a number of reasons. One of them is because you get really much more interesting and unique ideas when you get lots of different types of expertise together, because they will all think of something that you wouldn't, and so that gives you a really rich environment for innovation. Another is that if you involve someone in the process of designing something, they have some ownership over it. They're more likely to use it, and they're more likely to defend it. And so that's really important from a point of view of developing applications and services.